Hey, this is Toby talking about tech. So, um, what I have, hopefully you guys can see it. If not, I'll find out the hard way. But what I got going on is Delta Motion, and I'm actually I am in Iowa, and I'm connected to their test station, so to speak, in Washington, which a lot of people are talking about. Um, doing digital twins and stuff. But it's really cool that you can call up a OEM and say, "Hey, can I take a look at your software?" And they will set you up, and it's a free download, um, and they will send you documentation so you can connect to their test stations. Um, and we're simulating an actuator or hydraulic actuators and just doing some motion commands. And this is like a basic one. I don't have that much depth with it, so I just did something simple like this. These commands right here, 0 and 1, were already there, and they were talking to axis 0, which is this guy, and I just copied them and do axis 1 to see what I can do, right? And right now I have it in a closed loop stop, so I'm going to enable them again, and see if I can get it to go again and get it to move, and then just go through some of the benefits going on here for this software. So these are programs, and as you can see, it's super easy. Like I can change axes if I want in any of these. This is drop downs, and they tell you what the commands are. So it's super easy to program so far. Of course, I'm just doing something basic. So let's see if task 0 will go again, since I abrupted it pretty hard a while ago. Let's see if it'll go again without having to jump through some hoops. So, yeah, so little red showed up. She's moving through, and you can see the actuator up here is actually moving, and it's set. It's going to the position unit 5. Well, initially it's going to 10, right? And then waiting for the status bit. And the status bit is set. They actually simulate when you get to the end. If your stroke is like 0 to 10, then when it gets to the end, they're looking at like that you're on that position. So once it gets that bit set, it's going to the next move, which it'll send it back to 5. And I changed this because they were sending it back up this way and then just looping around. So I put it down to the second row because I wasn't sure how to get it to just follow through like they did up here. So I guess you could change these. And then I put the commanded axis here to move back up to move the axis 0. So it'll go 5 to 10, 4 to 8, 10 to 5. Actually, it goes back first. It goes 5 to 10, back to 5, 4 to 8, back to 4, and then back up here to the first one. Yeah. So these are your manual commands as far as this command toolbox over here. And you just choose the axes that you want to send commands to. There's open loop and closed loop. And this is what I find interesting, is that it just plots away, like, so you can watch the movement and tune it the way that you need to without, I don't know, it seems pretty easy if, like I'm not an expert on hydraulics, but the software tool seems pretty straightforward with if you wanted to be able to tune and work with the actuator at the same time, then you would be able to do so fairly fairly straightforward. So, and there's actually some tuning parameters there. And apparently they have a tuning wizard, which, you know, us in controls land, we know that could be good or bad. I could try to tune this one right now. I just wanted to show people the software and give a shout out to Delta Motion. And for you to be aware, the hydraulics motion cards, input cards used by Rockwell that were being made by Delta are going to be obsolete after this year. And if you look them up on Rockwell, they will be referring you to Delta. So, wonder if, I don't think I have a good website up right at the moment, but if you look at Delta Motion and RMC Tools, then you'll be able to find them. Cool thing is this, they stick things in registers just like everybody else does. And if you recognize something like this, you look at F8, F56 or whatever, you can be able to read from them and write to them via Word, and it will match up with your Allen Bradley or other, they do Modbus. So you can send commands directly from the PLC to this controller, or in certain cases, you may just want to use their controllers. This is viewing the modules, so this is the rack layout for what is going on for the station that I'm talking to. It's got 2 axes, obviously, because we got 2 of them going. Let's see what else I can share. He didn't tell me about this other stuff, but alright, so yeah, it shows us the 10100 Ethernet communications. As you can see, I go Ethernet, Profinet, control loop, firmware. So seems to me, yeah, so you can do voltages or current, depending on what you want to look at or how you want to use it. You have discrete I/O options for triggers, as far as like limit switches, etc. If you need to stop on a limit switch, something that he did tell me that was fairly cool is like these are position moves, right? And the one that we're doing is a position move. But you could, and I'd have to get offline and go do it, but you could have it so like in presses, you know, maybe you want to go faster, so you'll do a position move and you'll do an absolute like from top to bottom, and then as you get close to your hard stop and you get the spring force or whatever, you want to change from position control or velocity control to force pushback. So you can make that transition so that it can read the controller that they have can read not only how fast it's going, but if it starts getting a force that it doesn't like or that it's outside the parameter, then it will slow down based on that force and stop. So there's some versatility going on with Delta that I don't know, I think it's worth looking at. So anyway, that's just trying to show that you can be in Iowa and simulate hydraulic control in Washington. So call them up, let them know Toby sent you, and I don't know, do some hydraulic stuff. So pretty cool.